Alright, let's get started. We want to quickly type in a couple of small Java programs to understand how parameter passing happens in Java, as well as understanding how to use correctly setters and getters. Okay, very quickly let's discuss about a use case where we have typically tigers, and tiger has some muzzles and a name, and a tiger can eat a hippo, and typically we want to implement this. So we understand, let's make it a deer. So there is a tiger and there is a deer. Who depends on who is tiger depends on deer. So let's create a deer class. As per the good coding practice, we will store all our .java files inside of our development environment inside the source folder, and one class definition per file. Oops. And the name of the class is going to be the same name as that of the name of the file is going to be the same name as that of the class name. Okay, very good. So what does deer have? Let's say every deer has a name and every deer can run. So we understand that typically the methods will have an implementation which usually depends on the state of the object. So in this case, let's say when you ask a deer to run, it will say I am a deer with name, whatever is the name that is associated, running. Jump. That is now a simple SOP statement to indicate how deers run. So let's have a tester class, public class test deer. We will save it as testdeer.java, and the tester class is going to have our main method with the same method header as we are aware of. Typically what we can now do is create a deer object and assign a value to the name of the deer. Remember, we have created a deer object using the new operator. Deer D is a reference that is now pointing to the deer object. D.name is equal to Bambi. Bambi becomes a string object created on the heap. D.name is a pointer pointing to that string object. Now let's ask our deer to run by calling the run method. So d.run. Let's test this out first. Typically we will go to our source folder, verify our deer and test deer are there. They are very much there. So let's compile with the -d option, // classes. First we need to compile deer.java, then our testdeer.java. Both are compiled successfully. Come back to classes, verify the result of our compilation, deer.class, testdeer.class, java space testdeer. As you can see, we have asked the deer that we have created as an object to run by using the reference and by setting the name. So I am a deer with name Bambi running jump. That's all perfect. Now we want to have a tiger, so let's create a tiger class in a separate file, public class tiger. So tiger.java. So tiger has some muzzles. Let's say as per the analysis of the problem domain, we expect muzzles to be an int value, and a tiger has a name. First, let's verify how to generate correct setters and getters. We have understood that whatever are the hazard relationships we identify in the problem domain is what we associate and create as instance variables. One hazard relationship translates to one instance variable. The instance variable could be either a primitive or a reference, and typically because the instance variables values will depend or dictate the state, the behavioral output, what we are going to do is a two-step approach as a designer of a class. That is, first to declare all our state variables private, and second to expose setters and getters method. Typically one variable or each variable will have its own setter and own getter. What is the convention is all setters return void. The name of the setter will be a set name of the variable as per the naming convention as well. So public void set muzzles, all setter methods is going to take a corresponding data type of that particular variable that we are trying to set. The ideology is the user of the class is the one who is going to create an object. He needs to set the state, but we cannot trust him to set the state correctly, which is the reason why we expose a setter method where we consume his value that he passes. We will first sanitize the input by doing validations. Only if the input is proper will we associate it to our state. We protect our state because the state is very important. You cannot allow the state to be modified directly. The same is the case even in our real life as well. We have a state as a human being. Each one of us have a heart, liver, lungs. You cannot allow this to be used by the invoker. Maybe a girl will come in your life and say, give me your heart. That doesn't literally mean you give your heart access directly. God knows what she is going to do with it. Right? So that's why be very careful. Always give a copy. So that even if she does something, it's not going to affect you badly. Bottom line is the state impacts behavior, which is why we need to protect the state. Now, as a convention, we have exposed the setter method. Inside the setter method, what are we going to do is sanitize this input. We don't know what input this contains, n contains. It could be anything that the invoker has passed. So we will first verify as per the requirements of the problem domain. So if n is greater than 0 and n is less than some 21, which means n is the value from 1 to 20 because there is int values. Only then it is supposed to be proper will we associate our state variable with that particular passed value. It could be anything now, whatever the user has passed, but we have found out that it is valid, which is the reason why we can set the state. Else, what we are going to do is for now we will show a message, but we will replace this code, this type of coding by raising an exception once we learn about exception handling. Typically for now, we will throw a message. Okay, so that becomes a setter method. We understand that just having a setter method is like a one-way access. That means a user can now create an object of tiger and set the muzzles, but he cannot ever inspect the muzzles value, which is the reason why every variable will have a corresponding getter method also. What is the signature? What is the convention for the getter method? Is it will be a public method. The return data type will be the data type of that variable. Public int get muzzles, not get m, not get mus, it is get muzzles. The convention is important. Typically the getter methods will have more or less only one statement, which is nothing but a return the value of muzzles. Yeah, hello, any problem? Did I do something? Okay, now this is also getting recorded. Very good. No problem. So whether you set the muzzles or get the muzzles, typically whatever parameters are passed or returned, both of them happen by value only. So let's verify this. I want to verify this, but first let's make this work so that from a steps point of view we are clear what to do. So tiger t is equal to new tiger. First let's try to do this. T dot name is equal to Tiggy. We know that name is a variable, instance variable, which has been marked private, which means we, as a user, we should not be able to access it directly. Let's verify that first. So let's compile now our tiger.java. Compiled. Let's compile now testdir.java. Error. As you can see, the compiler verifies every statement, and what is the compiler saying is name has private access in tiger, which means we cannot access by using the dot operator directly. So that's perfect as per our understanding. So what we will need to do is to expose a setter method for name and getter method as well for name. So public void set a name accepts a string. For now any value for name is accepted, which means no boundary condition check, directly assign the value. Public string get a name, we just return a copy of the name box. This is the getter method as per the rules of how to create setters and getters. So what will the user do now is t dot, first he will create a string n is equal to Tiggy. Now he will say t dot set name of n, t dot set muzzles of some value. He can pass correct value, he can pass bad values. It's his wish now. The user is not bothered what value he will pass, but one thing is for sure, if he does pass a bad value, he is going to get scolded upon. Now let's make the tiger do something just for understanding how things work. Let's say a tiger can sing for reasons unknown, and the implementation is fairly straightforward. I am a tiger with name plus name singing chaya chaya. Amazing tiger it is. Let's say if the muzzles of the tiger is less than 10, it sings chaya chaya, else it sings I am a tiger with name plus name singing whatever is Doom machaye. Doom. My Hindi in English is terrible. Anyway, so this is now more relevant to the kind of methods that we will be coding, where what is it we have used as good practices, just to make sure that we are on the same page, is one, we have all state variables marked with private access. This is the first best practice. Second, all state variables have correct setters and getters. All setters validate the parameters before setting. If we have not done this, we should do this. Next, the state will impact behavioral output. This is what we need to follow as a good OO designer in every class that we design. Only then can we ensure that the contract of our class is valid, such that no matter how many objects of our class is created by how many users, all the objects will behave as per expectation. Is this clear? Okay, very good. So this is how we create setters and getters. Let's verify this working now. We have set the name, set the muzzles. We'll ask the tiger to sing. Both compilations successful. Now we run it. I am a tiger with name Tiggy singing Doom Machaye Doom. It's perfect because it has 10 and 10 is not equal to 10 or less than 10, which is the reason why the else block is executed. So if the user wants to set a bad value like T dot, what could be bad values for name? Tell me. We have not done validation check for name, isn't it? Whatever the user has passed as a string, we have assigned it to name. What could be a bad name? What could be an invalid name? For one, the user might give name as null. Wherever a reference is expected, what can be passed in its place is null, isn't it? Null is type compatible with all references. So null can be passed, and this is dangerous because the null is passed, then the tiger is nameless, isn't it? That is one. The other could be the user passes an empty string, nameless tiger, unnamed tiger. What is your name? If the user asks, if the invoker asks to a tiger, it will keep quiet. It will actually return, you won't even get to know that, isn't it? That is also a bad input. This is also a bad input. This is also a string only, a spaced string, some 10 spaced string. Obviously now we need to validate all this before assigning, before taking in the value. We will do that once we understand more about strings in the rest of the upcoming session. Alright, for now this is fine, but let's do this. Let's see what happens. T dot set muzzles of -10. Will this be allowed? Let's see what happens. So as you can see, T dot set muzzles, what it is throwing is this message: Yakappa, correct muzzles should be passed grr. So one thing is for sure, the muzzles of the tiger which has been created by us as a user doesn't have -10 as a value. But is it stopping me as a user to actually call the run method? I'm still able to call run method, isn't it? And what values of muzzle is actually being used to provide behavioral output? No, it's not -10. Less than 10. Why? What is the muzzles value of a tiger? No, it's not -10. Nah. The user is passing, the invoker is passing -10. But are assigning that minus 10 into muzzles? No, we are not assigning, which means what will be the value in this muzzles? 0, 0, very good. That means in the sing method, 0 is less than 10, so our tiger is singing chaya chaya. Should this be allowed? Ideally, if you throw exceptions, this will not happen at all. But for now, tell me how to fix this. How do I fix this? I don't want, even if a user passes in a wrong value, I am scolding him by the setter method. But I don't want him to call the behavioral outputs. I don't want him to call the behavioral methods. Oh, no exit. You can do exit actually, but exit will stop the program. You don't want to stop the program. For now, temporarily, what should we do?
Check the value and then call the.
Where do I check the value? If muzzles not equal to 0, means what? Tell me. If muzzles is not equal to 0, definitely what will muzzles contain? A correct value. Then I can do a check less than 10, greater than 10, give behavioral output. If muzzles is equal to 0, what does it mean?
No value is set.
User either has not set a value at all, he has simply created tiger and asking tiger to sing without setting muzzles only. If singing of tiger is going to depend on muzzle value, shouldn't the user first set the muzzle value before he asks the tiger to sing or not? But what is stopping him from simply doing tiger t is equal to new tiger t dot sing? He can do it. We should not allow that, isn't it? Or he could have tried to pass in a wrong value like minus 10. Either ways, now control is going to come to the else block. What we will do is will show a message. Maga first set madu, then sing method call madu. Now let's verify what happens. As you can see, we are trying to create a tiger object and pass bad values to it. Because we are passing bad muzzle value, we are getting scolded from the setter method. But now we are happily calling the tiger sing method. And what is the sing method doing? It is not providing the behavioral output. It is saying first set the muzzles, then only call the sing method. That means what we have done as a designer of a class is we have verified that no matter who is the user of our class, when he creates an object, he will necessarily have to give correct state by invoking the setter methods, only then invoke the behavioral output. And our behavioral output will never go wrong. Is this clear? This seems to be a lot of work, but there is no choice, at least for now. We have to do this. Any questions on why we are doing, how we are doing, how we are using setters or getters? Yes? Is it okay, guys? Or is it an overload? Overloading happens everywhere, in language and in real life also. Just kidding. Alright, so this is basically how do we use setters and getters. Okay. Now, very quickly, let me show you how to pass parameters with respect to references, because that is the only confusing thing that is there. Let's verify that, and then we can call this demo a break. We will take a break from this demo. Alright, so apart from sing, let's say a tiger can eat, and what can it eat is a deer. Remember, what can be passed as parameters are only variables or literals. So typically, how do you read this is a tiger can eat a deer. But what is being passed as the parameter is a deer reference. A deer object cannot be passed as a parameter. So just to understand parameter passing, I am a tiger with name, whatever is the name, eating deer with name, whatever is the deer's name. We are accessing d.name directly because d.name, deer's name is not given the private access. Otherwise, if we had to access the name of the deer, which would have private access, what we should have done? Very good. Let's do that. Private string get name, private string name, private void set name takes in a string. After validation, which we will perform after we understand strings, we will associate the value. Private string get name, we simply return the name value. Understood? Now, the user cannot access the name directly, but he can definitely ask d.getName, right? Fantastic. Let's verify how this works first. Then we'll play around with passing of parameters. Obviously now d dot name is no longer possible. I should do d dot set name. What I should pass as a parameter is a string reference. When I create Bambi inside of double quotes, an object of string is created and a reference is returned. That reference is I'm passing to d dot set name. I don't need to explicitly hold it in a variable and then pass it. So d dot set name of Bambi, d dot run. So deer is gonna run. Tiger T is equal to new tiger. String n is equal to Tiggy. T dot set name. We will give it proper muzzles. Let's say T dot set muzzles of 5. We are asking the tiger to sing and we are going to ask the tiger to eat. Whenever we call the eat method, we have to pass a relevant parameter of the correct data type. In this case, the data type should be of type deer reference. Let's call this D1. Or should we call that D1? D1. Okay. So we are passing D1. Remember, all parameter passing in Java happens by value. There is no pass by reference. All parameters are passed by value, which means a copy of the variable is now created as a local variable in the method that is being called in the local stack frame, and that variable will now contain the same value of D1, which in this case would be D. D dot name or D dot get name would access the same name of the tiger, deer. Sorry. Let's verify the working first and then we will play around with it. So as you can see, when you ask a tiger to sing now, I am a tiger with name Tiggy singing Chaya Chaya, muzzles 5. Obviously, if block is executed, else block is not executed. The tiger has perfect state, which is why it is behaving perfectly fine. Now, when you ask a tiger to eat and pass a deer reference, I am a tiger with name Tiggy eating deer with name Bambi. This is perfect. Is this clear? Okay, now let's try to do some breaking of the code. So D is equal to new deer, D dot set name. I can't access name directly, but D dot set name is equal to Bambino. Now, in my tester code, after I call T dot eat, of course, the deer should have died, but still we will ask the deer what is its name, and whatever is its name, we will print it out to the console. Is this clear? Now, in this case, tell me what will be the output? Okay, it should be Bambi. Let's verify. There you see, I am a tiger with name Tiggy eating deer with name Bambi. But what we have done is in our eat method, we are saying D is equal to new deer. That new deer has Bambino as its name, not the old deer. So no matter where D is going to point to, no matter what you change D to do, it is not going to affect D1. D1 will still point to same object that it is pointing to. It will have the same address value. So D1 dot get name will still have Bambi as its name. However, if we now try to set, instead of saying D is equal to new deer, whatever D is pointing to, that deer's name, if we change it to Bambino, what is now going to happen is when control comes back and we access D1 dot get name, D1 is still pointing to the same deer, but the name of the deer has changed in the method that we have called. So if you pass a reference as a parameter and the reference is used to actually modify that state of the object, that state object is permanent. That's why you see what is the name of the deer has now changed to Bambi. Is this making sense? Is this clear, guys? That is how parameters are passed by copy, by value, whether you pass a reference or you pass a primitive. A copy is what is passed. What you do to the copy is not going to affect the original. However, if you are passing a reference, using the reference, if you modify the state of the pointed to object, that state modification is permanent. Okay.